Hey guys, in this tutorial we're going to make a utility blueprint plugin that can be used to add useful functionality to the editor by using both utility editor blueprints and utility editor widgets. This can help automate repetitive processes that you frequently find yourself doing, and it will also include how to make a C++ static blueprint library so you can call C++ code directly from these utility blueprints or any other blueprints for that matter. So what I have here is just a tutorial project opened up. It's pretty bare bones, so you can get here just by creating a new C++ project in Unreal. And if you use Visual Studio, that's fine. You'll just use the Visual Studio build process instead of VS Code. So I'm going to start just by launching this project here and debug game configuration. And so we just have a default level here. And the first thing we want to do is create a new plugin. So if you go to Edit, Plugins, you can see the add button here at the top left. Go ahead and click that. And we want to create a blueprint library. Down here you can enter your plugin name. So we're going to be editing widgets or creating utilities for widgets. So I'm going to call this the Widget Tools plugin. And you can enter your author if you want or your description. And then when you're done, hit create plugin. There we go. And that might take a little while for you. Just be patient. It doesn't have any kind of progress bar. It just hangs for a little bit. So now I'm going to save the project and close it. And if you look at our project now, you can see there's a plugins folder that was created over here. And if I open that up, you can see there's a source and resources directory and a plugin file. So the first thing I want to do is, since this is going to be an editor only plugin, if you go into the plugin file, you can see this type runtime. You want to change this to type editor. So this will not distribute with the actual game. This will just be for the editor only. And you can also change your icon. Very important. Highly recommend this. So if I right click and say reveal, you can see it is just a PNG file in the resources directory. So I already have an icon here. I'm just going to copy it from my desktop and overwrite that. This will help you identify it in the list. And you can see that updated in VS Code now as well. So more importantly, if we go to the source folder, you can see there's private and public directories here. You can open both. And Unreal automatically created this Widget Tools plugin BP library class, and it has a sample function already declared for us. And it's already set up with a ufunction label to make it blueprint callable and to have the display name execute sample function. If we go into the CPP file and look at the implementation of this method, here's our sample function, and all it does is return -1 right now. So this is fine. We can make use of this. So if I launch our editor again, okay, if I go back to Edit, Plugins, and then go to Other, I just want to make sure that the plugin's enabled. You can see our icons there and the name. So it's all good. And now if we look in our tutorial project over here in the plugins directory, we now have a Widget Tools plugin content directory as well. And to start, let's just verify that that blueprint library is correctly added. So if I right click, I'm going to go to Editor Utilities and Editor Utility Blueprint. And you can see Editor Utility Widget is also here. And this is how we're going to add functionality to the editor. So the main difference here is a utility blueprint will just show up in the right click menu on assets, and a utility widget, we can actually add a custom user interface that we can launch from within the editor. So for now, we're just going to do blueprint, and we want asset action utility, and just give that a name, EUB, we'll call it widget tools. And if I open this, if you're familiar with blueprints for other uses, you've probably seen this graph before, but this is how you can add logic to the tool. So on the left here, I'm just going to add a function, and we'll just call it test for now, test function. And all we're going to do is just make sure that we can call our C++ library. So if I right click here and I type sample, if you remember the name of that function, it was called sample function. So you can see that down here. So we're going to execute our sample function in C++. And we don't care about the parameter, we can just leave that at 0. But if you remember, the return value was -1, so let's make sure that we're actually getting our return value. And if I type show message dialog, we can just display the return value as the message. And the blueprint editor automatically converts our float to a string. And we don't really care what the title is, so we'll just set that to whatever. Okay, so when we launch this test function, it's going to execute the blueprint library function in C++, and then it's just going to show a message box that shows the value that it returns. And we expect that to be -1. So I'm going to save and compile, close that. And now let me just make a test widget here that we can right click on. So it'll just be a user widget. So WBP for widget blueprint, test widget. And now if I right click on this, you'll see there's a menu that wasn't there before. It's called scripted asset actions. And the only thing in here is that test function that we just created. So if I click on that, you see we get our message dialog. It says whatever for the title and -1, which was the return value. Again, if we go back to our C++ code, -1 is the return value of that function. So everything seems to be working great so far. We can close that dialog. And one other thing to note is when in that right-click menu, the list of functions here is going to be the list of functions in our editor utility blueprints that apply to this asset. And I'll mention what I mean about apply in a little bit, but you can see if I open this back up and I add a new function, so some other function, and I won't make it do anything for the moment, but we'll just save that and compile. And now if we go back to our content and right click on it, you can see now we have some other function shows up. So this will just aggregate all of the functions in our utility blueprints. Okay, so I mentioned that there's another type of utility blueprint that we can add called a editor utility widget. So let's add one of those, and we'll name it EUW widget tools. And if I open this up, you'll immediately notice we have a canvas here now instead, and we can add UI elements. So let's just add a button, and we can put some text inside the button. And we'll just make the button size to content, and it's ugly, but whatever, good enough. So I'll save that and compile it. And if I close this, I can right click on that now, and I can say run editor utility widget. So we see we have a button here we can click now. Doesn't do anything, but hey, we have our own UI now. We can put whatever we want here, and we have a UI that we can control from within the editor, and we can even dock it if we want to. So we can stick it on the side here. So I'm going to leave that there for now, and let's make this actually do something. So just like in UI within a game, so to get this to do something, you can click on our button here, and we can add an event handler to it. So if I go down to onClicked, you can see I have an event node here, and we can do pretty much the same thing we did before. Let's just show a message box since we already know that our native script works. Give it a title. And just some message. And if I save and compile that, and we go back to our content directory, see now when I click the button, it updated live, and we get that message. So that we can write scripts for our user interface in the editor as well. So let's make it do something a little bit more useful. So the first thing I want to do, let's close this. We're just going to work with the utility blueprint for now. So I'm going to close, I'm just going to delete this one. So the first thing I want to say is you can make the scripts that you write be aware of what content was clicked. So if I go into widget tools, and let me delete these functions, we don't need them anymore. So let's say that we want to list all the widgets in the asset that we right click on. So let's say you right click on a widget blueprint and you want to print out the full tree of assets in there. So that only applies to widget blueprints, so we don't want it to run on like a static mesh or something that you right click. So if we go to the overridable functions here, there's this method called getSupportedClass, and in here we can return the types of classes that this should operate on. So if I click on here, I can type widget blueprint. And I can click widget blueprint here. So now, if I add a function to list the widgets in an asset, so we'll call this list, or let's call it log widget tree. So we have this log widget tree function. It doesn't do anything yet, but that's fine. So we'll save and compile. And if I right click on this editor utility blueprint, notice there's no scripting that's showing up here. But now if I right click on the widget blueprint, you see scripted asset actions shows up with our log widget tree method because this is a widget blueprint. So this is really powerful because now you can show tools based on the context of what was selected. So let's make this log widget tree actually work now. So if I go back to the C++ source, let's start to modify this sample function to do something a little bit more interesting. So we want to log all of the widgets that are in a widget tree from a given asset that we select in the editor. So let's start by just modifying this function. We don't need it anymore. So we're going to call this log widget tree. And it's going to take a U object. Now you could make this be a widget blueprint if you wanted to, but then you'd have to cast in the blueprint. So you either have to cast here or in the blueprint, might as well cast here. So we'll call this input asset, and it doesn't need to return anything, so that can be void. And we'll have the display name just be log widget tree, keywords, log widget tree. That should be it for the header file. So if we go to the CPP file, let me copy this. And log widget tree, return type void. And we will no longer return anything. So we're going to need a couple includes first. So let's include widget blueprint. And we'll include blueprint slash widget tree as well. So this input asset we expect to be a widget blueprint. So u widget blueprint. So we'll cast it. And if it's not null, and if it is null, we should probably tell the user that somehow, so we'll just log it for now. In order to log, we need a log category, so define log category static. Let's call it widget tools sub log all. And so if blueprint's null, we'll just log an error, UI log widget tools sub error. Text, the input asset cannot, or rather input asset must be a widget blueprint. So in this side of the if block, it is a widget blueprint. So let's get its widget tree. So widget tree equals blueprint widget tree. And now we want to print out all of the widgets in this tree, and we'll give them a number as well. So we'll count them, num equals 1, and then widget tree for each widget. And this takes a lambda. So we want to capture our num parameter so we can modify it. It takes a uWidget parameter. And then in the body, all we're going to do is UE log widget tools sub display, and we'll have it say widget by the number we're counting. And we're going to give it the name of the widget, of type of the widget. Now we can actually fill out those parameters. So we'll give it the number, and we'll give it widget get name, and widget get class get name. And because this is printf syntax, we actually have to dereference the f string to get the tcars underneath. And we want to increment the number each time. So now for each widget in the widget tree, it's going to say widget number, it's going to say the name, and it's going to say the type. And that's almost it. The only other thing we have to do is, because we're using widget blueprints and widget trees, we actually need to go to our build script, and under the private dependency module names, just add umg and umg editor. And if you don't do this, you're going to get linker errors when you build, because it won't be able to find the implementation of those classes. So that's it. So now we can, let's stop the editor we had before, and we can build again. All right, and before we use that function, let's make a test widget that we can try this on. And just to emphasize that you can use this in the project the plugin is a part of, we'll put it in the projects plugin directory. So I'm gonna right click, user interface, widget blueprint, user widget, and we'll name it widget blueprint test widget 2. And let's just put some content in here that we can print out to show that it's working. So we'll give it a canvas panel, and how about a vertical box within there, and then we'll give it a few buttons, and those buttons will have some text. And let's give the buttons names too, just to show that that part's working. So first button, and second button. And we don't really care that it doesn't look good, doesn't matter, but you can see the tree on the left here. We have a canvas panel with a vertical box and 2 buttons. So we expect all of these elements to get printed out when we print out this widget. So let's close that. And now we want to actually use the function we made. So we'll go back to our plugins content, and we'll open our widget tools. And now we're going back to our log widget tree function. So the first thing that we want to do is get selected assets. And what this node will do is, if I look at the content, if I right click on this, this is now selected, and this is gonna be returned by get selected assets. If I select multiple and I right click, get selected assets is gonna have all 3 of these in it. So the first thing we want to do is just get the first one, because we could actually do something fancy like iterate through and get all the widget blueprints in that selection, but just for sake of simplicity, let's just get the first one for now. So we got our list. We're going to get the length. We want array length. And we want the first index as well. So first we're just going to check that the length is greater than 1. So we'll do equals. And set this to 1. And then if that's true, we want to get the first array index. So get index 0 of this array. And we're going to do a branch. So up here is our flow control. So the condition is if the length is equal to 1. And if that's true, we want to do good things. If it's not true, we'll just show a message box. And we could say get literal, or sorry, make literal string. Say error in this case. And we'll just say, please select only one thing. Okay, but if it's true, then we want to call the function we just made with that first asset. So we wanted to say log widget tree. This is the function we just made, and we can get the first element of that array. Oh, excuse me. We want the plugin version of this. It's a little confusing because I named the blueprint log widget tree as well as the library function log widget tree. But in any case, we're going to get the input asset, and this will call our native function. So this is it. So when in the editor we call log widget tree, we're going to get all the selected assets. We're going to say if the length equals 1, then we're going to get the first asset, and we're going to pass it to our log widget tree method. If it's not, we're just going to show an error. So we'll save and compile that. And if I go to our content drawer, let's start just by checking the error case. If I select a few of these and I run our log widget tree, you can say we get an error saying please select only one thing. And if I right click on just the widget blueprint and I say log widget tree, now that should have called our code. And so I can check the output log. And sure enough, at the bottom it says widget tool sub widget 1. We have our canvas panel, we have the vertical box, we've got the first button, we've got the text in the first button, we've got the second button, and the text of the second button. So this successfully called down to our C++ method, and it printed out each widget. So this is an extremely powerful tool. You can do a lot with this. You can see basically anything you can access in C++ or blueprints, you can script now. And you can create custom UIs in the editor if you want, or for most things, you can just edit that right-click menu. So thanks for watching, everybody. That's going to conclude the tutorial for today. If you like the content, you can like and subscribe below. If you have any questions or you want specific things to be covered in future videos, you can let me know in the comments as well. And next video that will be coming out will actually be using this to do something more complicated and useful. And so stay tuned for that. So thanks again. Have a good day, everyone.